Alright, so in this video, we're going to be talking about integration with polar. Okay, so to do this, we're going to start off with just a circle. Okay, how do we find the area of a circle? Regularly, not even talking about polar here. Alright, well, we just use the equation area equals pi r squared, right? Of course. But what if we only wanted to find the area of the region shaded in green? Well, to do that, all we really have to do is still use our area formula, but instead stick out front theta over 2 pi. Okay, what this theta over 2 pi does is it takes into account how much of the circle are you trying to find the area of. Okay, of course, as theta gets larger, you're taking more of the circle, right? It's just basically, I mean, these are both angle measures, right? This is the whole circle, right? The whole circle is 360 degrees, and how much of that are you trying to find the area of, right? That's theta. So when you multiply this through, of course, pi's cancel out, and you're just left with 1/2 r squared theta. Okay? And that's basically it, okay? That is how you use polar to find the area of a circle. But what if it's not circular, right? What if you have this curve here kind of squiggly, maybe just anything but perfectly circular? Okay, well, now you have to integrate, okay? You have to integrate with very, very tiny angles, okay? So that's gonna be, it's gonna be in terms of theta. You're gonna get d theta, okay? The equation for that is now that the area equals 1/2 the integral from a to b of r squared d theta. All right, and well, all I did was I pulled out that 1/2. You don't have to pull out the 1/2 if you don't want to. All right, but I just changed the theta to a d theta because now we're taking infinitesimally small angles. Okay, we're adding up all of these, this term, right, and we're getting our area. Okay, so that's all we're doing. All right, so I'm just going to do a quick example of this, and that's going to be it. So we have our example up on the board here. We want to find the area of one loop of the four-leaved rows r equals cosine of 2 theta. So to do this, I mean, of course, hopefully you know like what r equals cosine of 2 theta looks like. I'm assuming you've at least by this point saw it 4 or 5 times by now. It basically is just this. If I can draw it, my drawing skills have not been known to be the best. All right, I'll take what I can get. It's this thing. Yep. And you basically just have your one little petal, I guess, going from negative pi over 4 to pi over 4. Okay? So if we wanted to find the area of this petal, well, we're going to be taking the integral from negative pi over 4 to pi over 4 of 1/2 r squared of d theta. Now, what's that r that we're squaring? Well, that's cosine of 2 theta. All right? Remember, since we have this d theta here, and our bounds are our theta bounds, right? We need for this r here, to be in terms of theta, okay? That's the only way this integration works. So, if we're ending up doing this here, now, one quick thing. This is symmetrical, okay? This is symmetrical above and below that polar axis. So what that means is that we can just say 2, actually, 2, and that's going to cancel out with the 1/2, okay? So we can actually just say the area of 0 to pi over 4 of r squared d theta. R squared, that's now cosine squared of 2 theta. Using our half angle identity here to break this up and get rid of this square, we're going to get area equals 1/2. We'll already pull that one out. This will now be a 1 plus cosine of 4 theta, d theta. All right, hopefully that looks familiar to you. Hopefully I didn't go too fast. Really, just breaking that up. And if this was just a cosine squared theta, it would have been a 1 plus cosine of 2 theta over 2. But since we had a 2 theta already in there, we had to make that now a 4 theta. All right, now just integrating here, we're going to get area equals 1/2 times theta plus sine of 4 theta divided by 4. And we're going to evaluate this from 0 to pi over 4. Now the 0 kills everything off, but the pi over 4, we can use that, right? We get 1/2 times pi over 4. And as you notice, when we plug in pi over 4 to this 4 theta here, we're going to end up with sine of theta. We know that to be 0, so we're going to get a plus 0 here. Altogether, we get an area of pi over 8. If you were asked for the area of the whole entire thing, okay, you could still just honestly start out with that integral that we did from negative pi over 4 to pi over 4, and then just multiply that by 4. Okay, I mean you can do that. There's nothing stopping you, and the area of the whole thing would just be pi over 2. Okay, so that's basically it for this video. We'll be doing example problems in the next couple of videos, and I'll see you then. So if this video helped you, make sure you leave a like and subscribe by clicking my icon in the top left. You could also view the playlist for